Welcome to Sundar's lecture. This is lecture number 13, and in this lecture we are going to see don't care conditions. In K-map, what is don't care condition, and if don't care conditions comes in the simplification of Boolean expression, then how we can do the simplification using the don't care conditions, right? So what are all the topics we have seen in the previous class? See, we have started with the adjacents of grouping of cells, 8 adjacent one each other. So what we have did, we have just taken some examples and just we have simplified the equations, right? Then we have taken some examples, right? Straight away we have gone for the minimization of Boolean functions using Karnaugh map. We are seeing for sum of product, not for the product of sum, right? So we have just simplified 1, 2, 3 and then 4, 5 problems, and in today's class we will also take the don't care conditions, right? What is don't care condition? In logic functions, the sum of inputs never appears. It don't appear, right? So the output of such inputs are not required. See, some inputs, for example, if there is an application, there are 15 number of combinations are there, and in those 15 number of combinations, I have only 13 combinations possible. Two combinations, there is no possibility for two combination. For example, if it is so, then for those two combination, for example, if you have a 4 variable system, 16 number of combinations, in those 16 number of combinations, 14 combinations I need, which means I need a binary solution. For example, if this combination comes, then the output should be 1. If this combination comes, then the output should be 0. For example, other two combinations, I have told you for 14 number of combinations, there are 16, right? So for other two combination, it never appears. So if it never appears, then what happens there? The output is not even required. It may be 0 or it may be 1. I don't care. That is what I have written here. Try to understand. In the logic function, some of the inputs never appear, so the output of such inputs are not required, which may either 0 or 1, right? So this is called don't care conditions. We generally denote it by D, and in K-map we generally denote it by X. It may be 0 or 1, right? How we can do the simplification if don't care condition comes, right? For example, we can take this as an this three variable K map now, and what it is actually. We need to see, again I am telling you the simple logic you have to keep in your mind. Our ultimate aim is to cover all the ones. That's all. We have to look for first octet, number 2 quad, number 3 pair. If these three possibilities are not there, then you can go for a single variable. That we have already seen. Right now, what you do, we have to simplify this one. What you will do now? See here, I can see for octet, only octet means all one should be there, right? So it is not possible because there is zeros. And what I can do further, I can go for quad possibility. If it is so, if I cover these two, see this x can be now considered as 1. Try to understand. This x can be now considered as 1. And what I am doing now, I need to cover these three ones, right? If I need to cover these three ones, if I can consider this x to be 1, let it be 1 or 0, it may be, right? That is what don't care condition telling you. And I can consider this x to be 1. So what happens now? These three ones can be covered with this x to be considered as 1 as a quad. Right? So what I can do now, this one, this particular thing, I can consider this as a quad, right? Quad number 1. And that's all. I have covered all the ones. I've covered all the ones, right? So what is the output expression? What is the output expression? Y should be is equal to I don't need to see these two because there is no common terms. What is the common term? It is C. That's all. This is the final answer. Try to understand. You should not make this as a pair, this as a pair here. That is my point here, right? And also you don't need to consider these x here. Again, you don't go here and you just cover these two as a pair or these as a quad again. No, no, no. You should not do that. Our ultimate aim is to cover all the ones. That is my priority. If I cover all the ones, even though there are x's available in other cells, I don't need to care. I can consider this as now 0 simply, right? So we will do with the practice. You can easily understand. Anyhow, now you take this example. Now what we can do? I need to cover these ones, right? These ones, right? So what I can do now? If I consider this x to be 1, this x to be 1, then what I can do? I don't go for this one, because if I go, I can take this. There is no octet possibility. First of all, there is no octet possibility, right? If there is 1 1, then I have gone for octet, but there is no octet possibility. So if I consider these two as x's as 1, then I can consider this as a quad, no problem. But what I can do here, I can also take this x to be 1, so that I can make this as another quad. That is one way of doing. See, try to understand. There is no exact answer required in the K-MEP simplification. Try to understand. There is no exact answer. Only how many quad and octet or pair possibilities are there. That's all. For example, if I output expression, maybe I will do this one. See here, what I can do now, I can consider this as a quad, right? Quad. Quad number 1. Quad number 1. I have considered this x to be 1. So this is 1, right? So what I can do now, I can consider this as a quad, right? So I need to consider these three ones now. So what I am doing, I am just taking this quad, this 4 as a quad, right? So this is quad number 2. So finally, what I can write, y should be is equal to quad number 1. So straight away you can write this is a bar b, and there is no common term here, right? So I don't need, right? So put plus, and you see here these two. I have to see these two cells. What is the common term? A is the common term, and I have to see these two cells. What is the common term? C is the common term. This is one type of answer. See what I am getting here. This is a quad possibility, quad number 1, and this is quad number 2, that's all. For the same example, what I can do, see, I will delete this one and I will do it again, right? I will delete this one. Whatever we have done, we can just go with another technique too. See, try to understand. I will make this one interesting to you, right? Now, in other perspective, what I will do, I'm just making this as a quad straight away. This as a quad, that is also possible, right? Try to understand. This is a quad number 1 for my view. This is quad number 1. Now I have these two ones. I need to cover it with the quad. Is there any quad possibility? Yes, there is a quad possibility. What I can do, I can consider this x to be 1. So what I can do now, I can make this as another quad. Right or wrong? This is also possible, right? What is wrong in this? This is also a correct answer. Try to understand. This is also a correct answer. See, for first quad, what is the common term in these two? B is the common term. And what is the common term in these two? C is the common term, plus. And for this quad, I have covered all the ones. Try to understand. That is why I have stopped. I am writing the expression now, right? And for these two, this quad, these two cells, A is the common term. And for these two cells, C is the common term. Try to understand. This is also a correct answer. And that is why I have told you there is no exact answer. I want to know what is the simplified expression. This is quad number 1. This is quad number 2. There is a 2 quad. Only 2 variables should come with 1 plus. That is the output equation. Try to understand. It is not the exact answers in Karnaugh map. The number of quad possibilities is the answer. If I put any pair here, then that is a wrong answer. Try to understand, right? So this is the basics of don't care conditions, and we will do some more problems, right? Okay. See now, we have taken two examples. Find the reduced SOP from the following expressions, and we need to, they will give you like this. For example, don't care condition if the question is like this, right? So what we can do now, I will just put the min terms here so that it will be easy. See here, I've just written the min terms, and now we can do this one, right? So sum is an m. These are all ones, and these are all don't care conditions. That's all, simply. So one, in one you have to put one, then three you have to put one, 7, and then 11, 15 is there, right? So put one. And the don't care conditions are 0, this is x, and for 2, this is x, and for 4, it is x, right? So these are all don't care conditions, and all other things are zeros. All other min terms will represents the zero output, right? Now I need to do this one. What we can do here? What we can do here? Let me suggest this one is very simple, right? What we can do, I have to cover this one is here and these two ones is a very simple problem, right? So first I will do this one, take this 4 ones, and is there any octet possibility? So I will go step by step. Is there any octet possibility? No, obviously no, right? I cannot go with an octet possibility. If this one, if there is all these all cells are 1, then I would have taken this one, and this one is an octet possibility, but there is no octet possibility, right? Here 0 0 0, there is no octet possibility. So I never take out, I cannot take the octet possibility. So this one will be a quad. So I have taken this one as a quad number 1. So I have just taken directly all the ones I have covered. And there is only one here. This one I have to take as a quad possibility. Is there any quad possibility? I have to check for the quad possibility. Yes, there is a quad possibility where it is. So see this one, these two x's can be considered as 1, so that this whole cell can be considered as a quad. To make this one into account, what I am doing, I am just making these two x to be 1, considering these two x to be 1 simply. So what I can do now, I can take this one as another quad, another quad. That's all. I have covered all the ones, right? I have covered all the. Don't go for this x. This x can be considered as now 0, simply because I don't need this one. I don't need this one, right? So this one, I'm just considering it to be 0, this x to be 1, this x to be 1 for this problem. So what is the final expression? It is now simple, right? Y will be is equal to, for this quad, CD is the final answer. CD, only CD. Why? Because only CD will come all these 4. You don't have any common terms, right? So CD. So put plus, and for this one, for this quad, A bar, B bar is the final answer, right? A bar, B bar. This we have already got, spend so many times to learn how to write the equations, right? Now this is the final expression for the first problem, and for the second one, maybe we try to write this one. What is this one? So this is the 1, and these are all x terms, right? So 0 0, and then for 8 it is 1, 11, and for 12, 15, and that's all, right? So 1 is x, 2 is x, 4 is x, 7 is x, 10, that is 10, 10 is x, and then 14 is x, right? So all other terms, all other min terms represents 0 output, 0 output. Right now this is the given question. So what I need to do here, I need to cover all the ones. That is my ultimate aim, right? That is my ultimate aim. What I can do here now, what I can do here now, see this one, see this one, these three one. Is there any octet possibility? This is 0, right? So I cannot go, this is 0, this is 0, this is 0, this is 0. And if there is any one here, so that I can make this as an octet. No octet possibility. So don't go to the octet possibility now. Right now, if I consider this x to be 1, what I can do? I can make this as a quad, right? This as a quad. That is a possible one. This one I can cover, right? So what I can do, I can take this as a quad possibility number 1. So I have covered these 3 ones with this quad possibility. So what I can do now, I can cover, I need to cover these 2 ones, right? How can I cover these 2 ones? Is there any quad possibility? Yes, right? This x can be considered to be 1. So that what I can do here, make this as a quad, make this as a quad. That is also a you can do like this, because there is no octet possibility, I have already told you. So what is this one now? This is now quad number 2. Quad number 2, that's all. I have covered all the ones, right? My ultimate aim has been completed. I have done, right? So what is the final expression? Y can be written as this one. We can straight away write this is C bar D bar, right? C bar D bar plus, and for this one you have to see what is the common term in these two, that is A I have written, and for these two cells what is the common term C. That's all. We have completed. This is the final expression. Try to understand, right? So we have simplified these two expression. This is for problem number 2. So that's all, right? So we have completed, and this is what the SOP functions, right? We have seen separately once without don't care conditions, and we have seen the problems with the don't care conditions also, right? So try to solve many problems, you will get a good idea. It will come by practice. Try to understand. It is like a logical thinking, right? Now what we will do, we will go to the new topic now. What is this one? K-map for product of sum. This is actually POS. Just you forget all the SOPs now. Come to me with the POS mindset, right? Only POS. So what POS, how POS functions will come? Try to understand how POS functions will come. We generally write Y will be is equal to A plus B plus C and dot A bar plus B bar plus C dot A bar plus B plus C bar, like this, right? Like this. This is the POS functions. And I have already told you the max terms will always result in 0. I've told you, just refer my previous lectures, min terms and max terms lecture. Max terms will always result in 0. So that max terms can be related with what? POS function. Behind max terms, POS functions will come, and I have already told you those basics, right? Now, how to write the KMF for the POS function? Now, for POS, for max terms, what we have written? For 1, you have put bars. For zeros, you will put the direct term. Like that. This is 3 variable KMF. No difference in the KMF. We have to split 8 different combinations will be there. Everything is same, like this, right? So, what you can do now, this is this is 1, this 0 and 1, 0, 0, 0, 1, 1, 0, 1, 1, those kind of things will be same. And for writing the POS function, what you need to do, for 0 you put direct value, direct variable A, and for 1 you put A bar, and likewise this is 0, 0, put B plus C, because it will be plus here. In POS function you have to put plus, right? You will get terms like this, and in the splitting terms, between two terms you will get a dot term, right? So you be very careful. And for this one, B plus, for 1 you put C bar, this is 1 here, so B bar plus, and then this is C, so directly put C. Likewise here both are 1, so B plus C bar, and likewise AB and CD, you have to write this one as same, 0, 0, 0, 1, 1, 0, 1, 1, 1, sorry, 1, 1, 1, 0, and then 0, 0, 0, 1, 1, 1, 1, 0. Those kind of things are same, but for zeros you put A plus B, for 1 you put bar, here also 1 you put bar, 1 you put bar, like that you have to write this one, right? So it is very simple, right? Now what you have to do here, for example, they have given you any questions like what to say, if they have given you any questions like this one, for example, you take this as a question now. So what is this one actually? Try to understand. It is very important to understand here. So A plus B plus C, right? So what is A plus B plus C? This is A plus B plus C, this term. What is this term? You have to put 0 here, not 1 now. You have to put 0, and you have to consider zeros now, simply, right? And then what is this term? A bar plus B bar plus C. A bar is here, whereas B bar plus C, it is here. So put 0 here. And this is A bar plus B C bar, right? A bar is here, B plus C bar is where? This way. You put 0 here, and all other terms are 1. So for our understanding, what you do, don't put anything. We don't need that, right? Because if you put 1, then you will confuse. You will be confused with SOPs and POS, where to map, and it will be confusing. So don't put anything. Just you do the simplification technique with this zeros. That's all. Very simply, right? Right. What is the final expression now? It is easy, very easy. Simply you can do these kind of things. What you can do here? Don't put again. You have to cover all the zeros now. You have to cover all the zeros now simply. So you can map these two as a pair now. These two as a pair. These two as a pair number 1. And what should be the output expression? What should be the output expression? I will write it in a different color. Y should be is equal to, you have to write this A bar. This A bar has to be written. A bar has to be written. And you have to see what is the common term in these two. What is the common term in these two? What is this one? I made any mistake? Okay, okay. This is 1110, right? That is what I have made a mistake. What I have to do now? See here, this is not 1011. This is 1110, right? 1110. So this will be B bar plus C bar, and this will be B bar plus C, right? So what is the common term in these two? In these two, C bar is the common term, right? C bar is the common term. So I can put plus now and then put not plus. Okay, fine. This is B bar plus C, right? So this A bar I have written here one term, single term, right? So single term means you have to put plus, and what is the common term in these two? C bar is the common term. So this is the for pair number 1. For pair number 1 I have just written. So you put bracket here. For pair number 1 I have just written, and for this one what you need to do, is there any possibility for pair? No possibility for pair, right? Because there is no anything adjacent to this particular cell, there is no zero. So you have to take this zero as a separate term. So what is the equation? It will come like, put a dot now, put dot for the second one. This is a separate expression. How I can write this one? This is A straight away. This is A, and what is this term now? B plus C. So it will be plus B plus C. That's all. So this is the final expression. This is the final expression. For example, you have some more examples so that you can understand, right? So what you can do? This is 0 0 0 0, and I am having 0 here, and I am having 0 here. For example, you take like this is 0. I have like this now. So all other terms are 1. All other terms are 1. Try to understand. I don't need to put the ones now. Yeah, don't ever put ones in simplifying the POS functions, right? So what I can do now? How I can simplify this problem now? I have to see for octet possibility. No octets possibilities are there because I cannot group 8 zeros together. So there is no octet possibility, obviously. So what I can do now, I can make this quad, this as a quad, right? So I can write this as a quad number 1. And the other term, what I can do here, I can map these two as a pair, right? So these two as a pair. So this is pair number 1. And what I can do with this now, what I can do, what is the possibility? This 0 can be, if I fold map like this, so this can be covered with this one. So this is a pair number 2. So how you can write the expression? Simply how you can write the expression, y should be is equal to, for this squad, what is the common term in these two? A is the common term, so put A in bracket, put A, and what is the common term in these two? C, right? So put plus C. That's all. This term has been completed. For this I have to put dot now and open bracket now. For this pair, straight away you can write like A bar plus B bar, this one. And what is the common term in these two? C bar. So put plus C bar. That's all. Put a dot now. Put a dot now. Put a dot now. Open a bracket now. And for this one, for this pair, straight away you can write C plus D. No problem. C plus D. But you have to compare this one and then this one. What is the common term? B, right? So put like B plus. That's all. Now this is the final expression. Try to understand. This is the final expression, right? So what you can do, you can go for another 2-3 examples, right? Look into this one now. Minimize this function. If they have given you pi m, what is pi m? It is the POS function. Try to understand. It always represents POS function. Try to understand, right? So you have to put zeros now for this one. So I have just written for 4 variable k-maps. I have written like this, right? So for okay, I have to write them in terms, right? Right. Now you see this one. So I have to put zeros for this one. So this is 0, and for 2 this is 0, 3 is 0, and then for 8 it is 0. 12 I have 0, so this is 0. 9 I have 0, right? So for 9 I have 0, and for 13 I have 0, and for 15 also I have 0. Right, now this is the given question, and what I need to do, I have to make these combinations, right? So what is the possibility now? And I have to look for the octet possibility. There is no octet possibility, obviously. There is no octet possibility. So for quad, I can straight away put this one, right? This cell. These 4 cells can be covered as a quad. So I'm just writing this to be quad number 1. And is there any other quad possibility to make this 0 or this 0 anything to take into account? Is there anything? No, right? There is no quad possibility, right? Again, for this 0 I cannot make any quad possibility. For these two zeros also I cannot make any quad possibility. For this 0 also I cannot make any quad possibility. Then obviously you have to go for the pair possibility. So this one, I'm just taking this to be pair number 1, and these two can be considered as a pair number 2. This is pair number 2, and for to account this one I can map this one and this one as pair number 3. That's all. There is no possibility, right? There is no possibility. So how I can write the expression? It is very simple, right? Y should be is equal to, put a bracket for this squad. What is the common term in these two? A bar is the common term. A bar is the common term. And for these two cells, what is the common term? It is C, right? So put plus C dot. I have done for this squad. And pair number 1, for pair number 1 straight away you can write this as A bar plus B bar, and then put plus, what is the common term in these two? D bar is the common term. That's all, right? Then put dot, and for the pair number 2 you straight away write this A plus B. There is no problem for A plus B plus, and what is the common term in these two? C bar, right? So that is this term, and put dot, and for pair number 3 straight away you can write this as C plus D, no problem. And you have to compare this one with this one. What is the common term? B is the common term, so B plus. That's all. This is the final expression, right? So we will go for this problem, and here you can have a don't care conditions, right? So what you can do now, I will just map it down. This is 0, 2 is 0, 3 is 0, 6 is 0, 7 is 0, and for don't care conditions, 8, right? So 8 is X, 10 is X, whereas 10, this is 10 is X, and then 11 is X, 15 is X, right? This is X now. So what I can do now, I have to cover all the zeros. That is my ultimate aim. Try to understand. Again, my ultimate aim is to cover all these zeros. So is there any octet possibility? Obviously there is no octet possibility. So what I can do now, I can make these 4 zeros, straight away these 4 zeros as a quad number 1, as a quad number 1. And what I can do, other 0 is here. Is there any possibility to get into account with another quad? No possibility, right? So I can go with the this one. Maybe I will take a different color. Right, this one and this one as a quad number 2. Sorry, pair number 1, right? Pair number 1. That's all. I've covered all the zeros, right? Straight away I can write the output expression. Y should be is equal to, for this squad, what is the common term in these two? It is A, right? So put plus, and what is the common term in these two? C bar. That's all. That is completed. Now for this pair, this is A plus B is a straight away term. I can write A plus B plus, what is the common term in this one and this one? D is the common term. So you can write D. So this is the final answer. This is the final answer. Right. Right now we have completed. Right. What are all the topics we have seen today? Right. It is very important. We have seen don't care conditions. In don't care conditions, what we have seen, if there is any input combination that is not required, that output may be 0 or 1, we can take that condition to be a don't care condition. And how we can map with the don't care conditions in Karnaugh map, that is what we have taken some examples and we have seen. And also we have tried to minimize the SOP functions with the don't care conditions, right? So for don't care conditions, you may consider or you may not consider that X to be 1, right? If you required to consider that X to be 1, so that the quad or octet or pair possibilities are available, you can do that, right? And we have gone for SOP function, POS functions, and we have simplified the POS functions, right? Thank you.